Hello everyone, I'm Singh Gambhir, third year student at IIIT Allahabad. Welcome to our channel, Learn Competitive Programming with CodeChef. If you are interested in competitive programming and want to learn and master data structures and algorithm, this is one-stop destination for you. Every week, we will be posting explanations to CodeChef problems, conceptual videos, and also conduct live problem solving sessions. Before we actually get started, make sure to hit the subscribe button. Today, we will be solving the problem named consecutive adding, which is a medium level problem. And to solve this problem, we require a data structure which supports two operations. Firstly, range update, that is adding a particular value in a range. Also, the second one is point query, which is basically calculating value of a particular element after all the updates have been done till this point. And both of these two operations should be in order of log n or less. So segment tree with lazy propagation or Fenwick tree along with the concept of prefix sum. Let's see what problem has to say. We are given two matrices A and B, each has R rows and C columns. So basically their dimensions are same. Also the ith row and jth column number, it will be represented by Aij and Bij in A and B respectively. Also we have number x and we need to perform some operations on A, and in each of the operation we need to choose an integer v and also choose x consecutive elements of A which are either in same row or in the same column, and then add this number v to all of those x elements. And the problem is to determine whether it is possible to change A into B by following these sort of operations. So basically we just need to add any number in x consecutive element of A which are either in the same row or in the same column, and just need to report that is it possible to convert A into B or not. This is the input output. Firstly, we will be given the number of test case, and for each of the test case we have n, m, and followed by x. Then we have matrix A which will be of size n cross m, and then matrix B which will be also of size n cross m. We just need to report yes or no. Yes if it is possible to convert A into B by following the operations, and if it is not possible then we just need to report no. So let's see the sample test cases. We have n is equals to 2, m is 2, and x is also 2 for the first test case. And the matrice A, which will be n cross m, it is this one of containing 1 2 0 1, and the matrice B, it is 0 0 0 0. So basically we want to convert this matrice A 1 2 0 1 into 0 0 0 0 by applying operations. So we need to select x continuous elements either from a particular row or from a particular column. Okay, so what we can do here is to select the first row, and then for selecting these two elements we would subtract -1 from these two, or we can say we are adding -1. Okay, then after this operation we are left with the array A as 0 1 0 1. Okay, and also now again we can apply the operation by selecting these two elements because x is 2, so we need to select two continuous elements, and we are selecting it from the column number 2 this time. And if we add -1 in both of these two elements, then we will have a matrice which will have 0 0 0 0, and this is what we want because this is the value of B as well, which is 0 0 0 0. So here we are able to convert the initial given matrice A into the matrice B. So we just need to report yes for this particular test case. Let's see the second test case. In the second test case also we have n, m, and x all being 2. This time the matrice A is 1 2 0 1, and we need to convert into the form of 0 0 -1 0. So let's see how we can apply some operations and get to this particular matrice B. So for these two elements, if we select, we will do a operation -1 because we need to make this particular one equal to the corresponding element in the matrice B. Okay. So if we apply this operation -1 on the first x elements of the first row, then we have 0 1 0 1. Then again for this particular A, we can subtract -1 from these two values as well because x is 2 here. So by this operation we have 0 0 0 0 as a, but here b was 0 0 minus 1 0. If you see, for these two values we have a as this and b as this. In this case, all these three elements are equal, both in A and B. So if you apply any operation including them, then they will not be equal because this time they are being equal. And suppose that we add 1 in any number, so obviously it will not be equal now. But the only number remaining here is this particular number, which is 0 in A and minus 1 in B. So this particular number, it is not equal, and no more operations can be applied here because x is 2. So at least we require two elements to perform any operation in A. And if you choose two elements in A, so obviously we are like, for the element which is already being set, means it is equal to bij, so we are unsetting it, so it is not favorable. So in this case we need to report no, because it is not at all possible to get to matrice B from A. Let us see the solution of our problem. We had the array A, which was 2D array basically of size n cross m. Let us see what operations we can apply on the first element, which is present in the first row and first column of the array A. So this is the first element. Suppose that this first element is not same in the B array. So we need to apply some operation and make it equal to that particular element in the B only. So what are the operations that we can apply in order to change this particular element? So there are two operations possible. Suppose that we could include this particular element in the x consecutive element in this particular row. Or another operation could be, we can select this particular element as a part of x consecutive elements of that particular column. So these are the only two possible operations which can result in change of this particular element, which is the 1, 1 element. Let us see an observation that how these are equivalent only. So let us suppose the value of x is 4. And you wanted to apply the operation by taking 4 number of element from the particular column, but instead we have applied the operation by taking 4 number of element from the particular row only. So we need to prove that these are equivalent operations only. So we will apply further more operation on rest of the elements so that finally we can get this particular state only. As the number of operation are not in a limit, it is just that we need to find yes or no as the answer. So there is no problem in applying more operation. So in order to convert this particular matrix into this form, we can apply an operation by taking 4 elements and adding minus s in these. So we will obtain a matrix such as and these particular element will be 0 only, so it is like unchanged. And also we can apply now operations like these. We can select 4 elements, and now in this case we need to just add s in all of them. So we will have this as our final matrix, which is similar to the one which we required. So from here we can conclude that if you want to apply the operation by taking x element from the particular column for any element, and instead of that particular operation, if you apply operation by taking x element from the row by including that particular element, then these two operations are similar only. We can reach to the same state, just it is matter of some extra operations only. And one more thing to note here is that we didn't even touch this particular element. Like we have only applied operation on the rest of the elements and then reach this as the final state. Okay. And also here we have taken the value of x is equals to 4, but it doesn't matter because it will be like true for all the values of x. Just here to show visually, I have taken this value 4, but it will be obviously true for all the values of x. And similarly, we can also say that if you wanted to apply the operation on the row and instead of that particular operation we have applied the operation in the column, then it is also equivalent, because by applying further more operation on the rest of the elements only we can have the same state. So let us see this with the help of an example. This is our previously taken example from the sample test case, and the answer for this was yes, because for this particular matrix we need to convert it into the form of 0 0 0 0. So the operation which we had applied was subtracting -1 from these two elements and again subtracting -1 from these two elements. As x was to 2, so we could obtain the matrix 0 0 0 0. So here, as we had applied the operation on this particular row only, let us see how we can achieve this particular matrix 0 0 0 0 only if we had applied operation on the particular column. So for this particular column, if we subtract -1 from these two elements, we will have an matrix which will be 0 -1 2 1, and further operations which we are required to apply are, we can subtract -2 from these two elements. So we will have 0 0 -1 -1, and now furthermore we can add 1 to these two elements and we can reach the matrix 0 0 0 0. So here point to conclude is that the answer can be reached in the form of both the ways. Either we can also apply it like operation in the particular row or in the particular column as well. Both are equivalent only. So till this point we have seen that for the particular element 1 comma 1 we had two operations only. First was including this as the top of the x element from this particular column, or we can include this as the first element in the x consecutive element for this particular row only. And also these two operations are equivalent. Let us see how we can change the element 1 comma 2. So the operation possible are, either we can select x element like this, or we could select x element like this, and also there is one more operation left. So in order to change this element, which is if we take x element like this. But one thing to make note here is that suppose that we have already set this particular a11 equal to b11, and if we apply this like third operation which we have marked, so it will change the value of a11. So we do not prefer to apply this operation. So now the only operation left are these two only. And also we have seen that applying the operation in the form of like taking this particular element as the leftmost of the x element in the row, or if it is like top of the x element in the particular column, these operations are equivalent. So doesn't matter, you apply any of them. So let us see what happens if we want to set a particular element I comma j set equal to the bij. Okay, so when we are concerned about the particular element ij, then already all the elements which has row number less than I are being set. So these particular values are same in the b and a matrix only, and all the elements to the left of this particular element which has like row number I and column number less than j are also set. So the operation left to change this particular ij are two only. Include this particular ij as the part of the x element in this row operation, or we can use it as a part of the x element in this form for this particular column operation. And we have already seen that these two are equivalent only. So it doesn't matter, you apply any combination of these two. So let us conclude what we have done till this point. We will be operating row wise, column wise, and when we are concerned about any particular ij element, then these particular element are already being set. So if you have x element in the row for this particular element, like we have x element after this particular element in the row, or if you have x element in the column, so these are the operation possible, and you can apply any of those only. Suppose there are not x element present in the row, then the only operation left to set this particular element of the A matrix to equal to that of the B matrix is to apply this operation. And same goes with if there are not x element in the column. So then only possibility is to apply the row operation only. But what happens if there are not x element either in the row or in the column only? But this particular element is not set. So we need to apply operation on this particular I comma j. But as there are no operation possible, so we cannot change this element further. In this particular case, we need to output no as our answer. This particularly the no thing, it is quite difficult to digest. So let us see this with the help of an example. In this particular example, we have n as 3 and m as 2. Also, the value of x is 2. This is the matrix A and this is the matrix B. Okay. So let's apply operation on the matrix A and see that are we able to make it equal to the matrix B. These elements are already being set, so we do not want to touch them. Okay, so now the operation we can apply are on these three elements only. We want to make this particular element equal to 0, so we can subtract 1 from these two elements. Now we have 1 2 3 0 1 3 as the matrix A. Now we can apply operation by taking these two elements and adding -1 to these two. Then we can have 1 2 3 0 0 2. Okay, so at this particular point we have our array A as 1 0 2 0 and 3 2, but the matrix B was 1 0 2 0 3 0. So if you see here, the 5 elements are already being equal. Okay, and the only element left is this particular element, and clearly as x is 2, so we cannot change only this particular element. We at least require 2 elements to change, and only this particular element is left. So this is like maximum close we can come to the matrix B, and even this at this point also it is not being equal, so it is not possible. So let's see the code implementation. The basic logic of the code is we are maintaining n segment trees each for the row, and we are also maintaining m segment trees each for the column. And if we apply operation in a row, suppose that we are applying an operation in the row I, then we will update the segment tree of the row for the index I. So for each of the test case, we need to clear the variables globally, and then we would call a function named solve, which will be responsible for answering for each of the test case. For each of the test case, we are first getting input n, m, and x. Then for the matrix A, its size will be n plus 1 cross m plus 1 because we are using one based indexing. Similarly, for the matrix B, this particular thing t underscore row, it represents the segment tree of all the rows, which is basically containing n plus 1 segment tree because we are using one based indexing here also. And for the size of each of the segment tree, it will be 4 times the maximum number of element, which is m. So we are as we are using one based indexing, so this particular terms come out to be 4 times m plus 1. Similarly, with respect to the column, its size will be 4 times n plus 1 times m plus 1, because we are using m plus 1 different segment trees each for each of the column. This part is responsible for taking the input A and B. Before coming on to the main logic, let us see what this function get row and update row, update column, get column does. Okay, so these are similar function, update column and update row. It is on the similar way, and this get column and get row is on the similar fashion because it's just the difference of row and column segment tree. So let us see one of them. Okay, so update row, it will take the row number as the argument because we need to access the segment tree at that particular row. This V represents the answer for the range TL to TR, and this is the range which we need to update. From the index L to index R, we need to add this term add. Okay, so this is like quite standard thing if you know the lazy propagation in the segment tree. And this particular function get row, this is responsible to obtain the value which is present in this particular row, and its the column number is this position. Okay, where V represents the node and TL and TR represents the range of which this particular V is the answer. And this is nothing but the lazy implementation. So it is like quite standard. Okay. And similarly, in the same fashion as we have done for the row, this is done for the columns. Okay. Now comes the main logic. For each of the elements, we will get what is its current value. So we will be getting, like, for all the number of operations which we have applied in the row, we will get its sum, and then similarly for the column, also the initial value was aij, and the final which we want is the bij. We will calculate its difference, because this current plus aij represents what is the current value of the particular element ij, and what we want finally is bij. So basically this is the difference which we need to compensate. Okay, if this difference come out to be 0, so nothing is required to be done. And if this particular difference is non-zero, then we need to update, either select x element from the column or x element from the row. So if there are x element present in that column, so we will update the column, and if there are x element present in that particular row, then we will update that particular row. And if this is not that case, then we need to output no, because difference was non-zero. So this particular element is not equal to its corresponding element in the B matrix basically. So if this is not equal and we are not also applying any sort of operation, so obviously this is not possible that this particular element will be equal. So we need to output no and then return from here. And if for all of the elements we do not get this no, then we need to just output yes, because now it is possible for each of the element to be equal to their corresponding element in the matrix. So let's submit our code. Also, did you know that CodeChef also conduct free live classes on Unacademy, where we teach every possible topic related to competitive programming? These courses are conducted by top coding experts who have been ICPC World Finalists and are also highly rated on various coding websites. You can use my referral code MEET10 to subscribe and get an instant 10% off. We have an AC. That's it for this one. Make sure to like the video if you gain something out of it. To submit your code even after the contest ends. In case of any sort of doubt or feedbacks, feel free to leave in the comments.